Subscribers to In the Beginning receive carefully researched ebooks, detailed videos showing real woodworking projects built step by step, and exclusive timber-related material that isn't published publicly. This work is slow, deliberate, and grounded in material reality. If that approach matters to you, you'll find value here. Most people assume nails made buildings stronger. That assumption is one of the quiet reasons so many wooden structures fail earlier than they should. Long before mass-produced metal fasteners, carpenters built structures that endured centuries of movement, moisture, load, and neglect. When nails became cheap and common, construction got faster, but timber behavior was no longer being respected in the same way. The loss wasn't just aesthetic or traditional, it was structural, mechanical, and long-term. This isn't about nostalgia or rejecting modern tools. It's about understanding why older joinery worked so well, what it accounted for that modern fastening often ignores, and how wood itself responds over decades rather than seasons. Old carpenters didn't distrust nails, they distrusted rigidity in a living material. Wood moves. That's not a metaphor or a general statement. It expands and contracts across the grain with changes in humidity. It creeps slowly under constant load. It shrinks as it dries over years, not weeks. Pre-industrial carpenters understood this through observation, not charts. They saw beams pull away from pegs, posts twist out of square, and roofs settle unevenly when restraint was placed in the wrong direction. Nails lock wood fibers in place. When the surrounding timber wants to move and the fastener doesn't allow it, stress accumulates inside the wood itself. Over time, that stress shows up as splits radiating from nail holes, crushed fibers around shanks, and loosened joints that were once tight. The failure often looks sudden, but the cause is slow and cumulative. Traditional joinery avoided that problem by transferring load through geometry rather than friction. The joint itself carried the force, not the fastener. The core method was joinery that locked under load instead of fighting it. Before nails dominated construction, structural frames relied on mortise and tenon joinery, often reinforced with wooden pegs rather than metal. This wasn't decorative joinery, it was load-bearing, engineered to work with gravity, compression, and seasonal movement. A properly cut mortise and tenon allows a beam to seat deeper as weight increases. The more load placed on it, the tighter it becomes. The wooden peg, usually driven slightly offset from the hole in the tenon, pulled the joint together under tension without rigidly fixing it in all directions. This technique, known historically but, rarely discussed today, allowed micro-movement without any loss of strength. What really matters is that the joint could breathe, wood could swell and shrink without tearing itself apart. Stress was distributed across broad bearing surfaces instead of being concentrated at a thin metal shank. Wooden pegs weren't weaker than nails, they were actually better matched to the material. A common modern assumption is that wooden pegs were used just because metal was unavailable. But in reality, pegs were often actually preferred even when nails existed. A dry hardwood peg, driven into greener surrounding timber, would swell as moisture equalized, tightening the joint naturally. Over time, the peg and the surrounding wood would age together. Metal fasteners introduce a material with different thermal expansion, corrosion behavior, and stiffness. And, in damp environments, nails create localized decay zones where moisture condenses around metal. In old structures, you can often trace rot patterns that follow nail lines rather than wood grain. Wooden pegs avoided that. When they failed slowly, visibly, and in a way that could be repaired without dismantling the entire structure. These joints assumed buildings would move, settle, and age. Old carpenters, did not expect a building to remain perfectly square forever. They expected posts to settle into the soil, beams to deflect just a bit under load, and walls to shift with the seasons. Joinery, it accommodated this by allowing rotation and compression where necessary. Sills were often isolated from ground moisture with stone not sealed rigidly in place. Roof structures relied on triangulation and bearing rather than nailed shear resistance. The building acted as a system, not simply a collection of rigid connections. When nails became dominant, construction shifted toward locking everything in place as tightly as possible at the moment of assembly. That approach works well in the short term, especially with kiln-dried lumber and controlled environments. Over decades, especially in variable climates, the weaknesses begin to show. Failures in older buildings often tell a different story than people think. In reality, many failures happened where later repairs introduced nails, bolts, or rigid plates into systems that were never really designed for them. A pegged joint, when replaced with steel brackets, actually becomes a stress concentrator. Movement that once used to distribute harmlessly now, unfortunately, tears fibers apart nearby. Surviving medieval barns, timber-framed houses and bridges didn't last because they were just overbuilt. They lasted because, honestly, they were correctly built for wood as a material. Where they failed, it was often due to water intrusion, ground movement, or later interventions that honestly ignored original design principles. Understanding this, it really changes how you evaluate durability. Longevity isn't about stiffness alone, it's about compatibility. This method demanded more skill, time, and understanding than nails ever did. A poorly cut mortise actually weakens a beam more than a nail ever would. That skill barrier is part of why the method faded. Industrialization really rewarded speed and standardization. Nails allowed unskilled labor to assemble frames quickly, but honestly, the cost was paid later, long after the builder was gone. For old carpenters, reputation extended beyond their lifetime. Buildings were expected to stand long enough to judge the maker's work. That alone shaped different priorities. The lesson isn't to abandon nails, but to stop pretending they're neutral. Modern construction has its place. Nails, screws, and engineered connectors solve real problems when used correctly. The mistake is assuming they replace understanding. When nails are used where joinery should carry the load, wood pays the price. For timber structures meant to last, especially in off-grid survival or low-maintenance contexts, historical joinery offers principles that, honestly, still apply today. Load paths matter. Moisture pathways matter. Allowing wood to behave like wood really does matter. These lessons aren't obsolete. They've simply been buried under convenience. Understanding old joinery is really about understanding wood itself. Wood is not steel. It is anisotropic, hygroscopic, and time-dependent. Old carpenters didn't need those words to respect those facts. Their methods, honestly, encoded material science into practice. When you study historical joinery, you're not just learning tricks, you're learning how previous generations listened to the material and, adjusted their designs accordingly. Understanding why nails weaken buildings isn't really about rejecting progress. It's about reclaiming knowledge that was, you could say, earned slowly and lost quickly. If this kind of grounded, material-focused understanding matters to you, then consider subscribing to the In the Beginning email list. This work, honestly, continues beyond videos, and the deeper lessons don't belong to algorithms or trends. They belong to anyone willing to take wood seriously on its own terms.